This lesson focuses on adding two rational expressions, and the rational expressions that we're going to look at in this lesson will have the same denominator. So just remember about adding two fractions. So when you add two fractions, let's say we had 3/7 plus 2/7. When we add two fractions, remember they must have the same denominator in order for us to write it as one fraction. So in other words, in order for us to be able to say that 3/7 plus 2/7 equals a fraction, one fraction, the partitions or the denominators have to be the same. In this case, it is. So once the denominators are the same, we have 3/7 plus 2/7. Then that means then I have so many sevens. All right, so the denominators are the same. So I have 3/7 and then another 2/7, and altogether I have 5/7. So when adding two fractions, remember we have to make sure that the denominators are the same, and that all we need to do then is just add their numerators. Okay. Now let's look at some rational expressions where we have variables involved instead. So let's just look at number one. So the directions will usually say something like add, since we're adding here. Or if we were subtracting, it would say subtract. And if it was a mixture, probably would say add or subtract as indicated, or perform the indicated operations. Things like that. In this case, I'm just going to say add. So number one, we have 3x divided by 5 plus 2x divided by 5. All right, so I have two rational expressions, and notice that the denominators are the same. So if the denominators are the same, it makes things so easy for us, because once we add them, then everything we do after that point is based on information you already know. So when I add these, since the denominators are the same, I know that my denominator in the answer is going to be a 5. Well, if I don't need to reduce, so far I have a 5. And all I do is add the numerators, and notice, and most students don't need to do this, but if you do, that's fine. You go off to the side and you look at your numerators. So I have a 3x and I'm adding a 2x. And notice I can combine these like terms. So these are like terms. So 3x plus 2x is 5x. So I'll put the 5x here. So I have 3x fits plus 2x fits. So altogether I have 5x fits. Okay, now once you get to this point, you need to notice that I can reduce. Okay, so you must reduce. And so therefore the 5's divide out. So remember you when you divide out factors, you need to put factors of 1 in their place. And so therefore you just get x as your answer. Okay? All right, number 2. Number 2, we have 3 divided by n plus n plus 5 divided by n. All right, so notice the denominators are the same. So once the denominators are the same, I'm going to write this as one fraction with that denominator. And then my numerators, I just combine like terms if I can combine like terms. So for example, I have 3 plus n plus 5. And when I combine like terms, I can combine the 3 and the 5, so I get n plus 8. And that's going to go here. All right, and then I can't reduce anything, so I'm done. That's your answer. All right, number 3. Now again, just to let you remind you, you can't divide out these n's. You know that, right? Because this n is not a factor. You can only reduce. You can only divide out factors. 5 is a factor. X is a factor. Remember, factors are separated by products. 5 times x. That's the only thing you see here. So 5 is a factor, x is a factor. And then 5 is a factor down there. Here, though, together n plus 8 is a factor. Okay, so don't say n's a factor or 8's a factor and try and reduce these n's. You cannot do that. That's not a correct statement. Okay, so that's why it's important that in our lessons that we've learned previously that we always talked about, make sure you recognize your factors and then divide out common factors. All right, so your factor here is n plus 8. I don't see an n plus 8 in the denominator. Okay, number 3. Let's suppose number 3, we have 1 divided by x plus 5 plus x plus 6 divided by x plus 5. So again, the denominators are the same, so I'm going to write this as one rational expression with that denominator. All I have to do now is add their numerator. So I have 1 plus x plus 6. When I combine like terms, I get x plus 7. And so that's the numerator. And notice I don't have any common factors. My factor here is x plus 7. My factor here is x plus 5. I don't have any common factors. Okay? So that's your answer. Number 4, we have, let's see, 5x divided by x plus y plus 5y divided by x plus y. All right, so notice I'm adding two fractions with the same denominator, so I'm going to combine this into one fraction with that denominator. And then if I look at my numerators, this term and this term, they're not like terms, so I'm going to just go ahead and write this as 5x plus 5y. All right, now, at this point, this is where we're going to start looking at some rules, okay, some steps. So when I get to this point, remember one of the first lessons we talked about when we started talking about rational expressions is that we had to simplify rational expressions. Do you remember the steps to do that? This first step you need to do is you got to factor. Okay, so you got to factor your polynomials. All right, so if you notice, I can factor this. So the numerator, I'm going to get 5 times x plus y divided by, and I cannot factor this denominator, so I'm going to leave it as x plus y. Then the next step, remember, is to reduce, just like we did in the very first problem. Reduce. So when I reduce, the x plus y's divide out. So again, don't just strike out the x plus y's. Remember, those are factors of 1's in their place, so make sure you do that. Because if you have anything that are opposites, remember, if they're opposites and you just strike it out, you're gonna forget that one's positive and one's negative. Okay? And so therefore the answer is just 5. All right, so now you got to remember that when you get to this point right here, when you add those two rational expressions into one rational expression with that denominator, you're now going to factor. And then once you factor, the next step is to reduce. Okay? And then you get your answer. All right, number 5. Number 5, we have 8x plus 1 divided by 7x minus 3 plus 2x plus 7 divided by 7x minus 3. Okay? And so notice the denominators are the same, so I'm going to go ahead and add their numerators. So I'm going to end up with a fraction with this denominator. Now look at your numerator. So if you think about it, I have 8x plus 1 plus 2x plus 7. Okay? So in a previous course, you learned how to combine like terms. So 8x and 2x is 10x, and then 1 plus 7 is 8. Okay? All right, so once I get to that point, remember I need to factor now. So let's factor and see if I can factor out common factors. So when I factor, I can factor out a 2 from the numerator, and I get 2 times 5x plus 4 divided by, and I can't factor the denominator, so I'm going to leave it as 7x minus 3. All right, now the next step is to reduce. So remember, you factor, and then you reduce, and in this case I can't reduce, there's no common factors. Here my factor is 2, I don't see a factor 2 in the denominator. Here my factor is 5x plus 4, I don't see a factor 5x plus 4 in the denominator. In fact, the only factor you see in the denominator is 7x minus 3. And so therefore that's your answer. All right, number 6. So it's fairly easy. It's adding rational expressions, whether adding or subtracting rational expressions with the same denominator is fairly easy. So in the next lesson, we look at subtraction. It's the same as adding, the steps and all, except this will be a subtraction symbol. Okay, number 6. Number 6, let's suppose we had 3x minus 7 divided by x squared minus 7x plus 12 plus 3 minus 2x divided by x squared minus 7x plus 12. All right, now notice that the denominators are the same. Okay, the denominators are the same, so I'm going to write the first step. Once the denominators are the same, the first step is to write this as one rational expression with that denominator. Okay, then the next step is to combine your like terms in the numerator. Add those two numerators together. So if you think about what you have, I have 3x minus 7 plus 3 minus 2x. So let's go ahead and put this in descending order. So let's combine the x's first. So 3x minus 2x is x. A negative 7 and a positive 3 is a negative 4. So that's where I'm at. Okay? All right, now remember the next step, once you get to that point, the next step is to simplify this rational expression. Okay? Remember the steps. You need to simplify your rational expressions just like you did in a previous lesson. And so when I say simplify the rational expression, I'm talking about this point here, not these, this. Okay? You want the denominators to be the same. So once you get the denominators to be the same, then you get to that point and you simplify this. And to simplify this, you're going to factor. So I cannot factor the numerator because that's linear and the GCF is 1. But look at the denominator. If you look at the denominator, I can factor that. I can factor the denominator. And when I factor the denominator, it looks like I'm going to get, the last sign's positive, so that's an easy one. Okay, they're both negatives. And then I need factors of 12 that will give me a negative 7x. And so that looks like 4 and 3. All right, so I get to that point. So I factored the denominator. Now the next step is to reduce. So these x minus 4's divide out, and I'm left with 1 divided by x minus 3. And so there's your answer. Okay, so very simple because you've already done the bulk of your learning in previous lessons. The only thing you need to do now is just remember that you're adding two rational expressions, but the procedure's the same as you would when you were adding just two fractions that were numerical. All right, number 7. Let's suppose number 7 we had this for number 7. Let's see. Let's suppose we had this. 10x plus 8 divided by 6x plus 5. And you're adding that to 14x plus 12 divided by 6x plus 5. All right, so I want to add these two rational expressions. The denominators are the same. So I know that I'm going to end up with the next step will be one rational expression. I can combine this into one rational expression with that denominator, just like that. And then all I do now is just add their numerators. And again, you don't need to keep writing this down because most of you can possibly do this very easily in your head. So for example, 10x and 14x is 24x. A positive 8 added to a positive 12 is a positive 20. Okay, so that's where we're at. All right, now the next step is to factor. So you want to simplify this rational expression. So to simplify this rational expression, you need to factor and then reduce. So if you look at the numerator, it looks like I can factor out a 4. And so I get 4 times 6x plus 5. The denominator is 6x plus 5. Okay, so I factored. So remember the next step is to factor. All right, so you want to simplify this rational expression. So you're going to factor and then reduce. So when I reduce, these divide out. And I get 4 times 1 is 4. And 4 divided by 1 is 4. All right, so the answer is 4. Okay, number 8. Let's suppose we had this in number 8. All right, let's see. Let's suppose we had x squared minus 3x divided by x squared plus 8x. And then you're adding that to x squared plus 6x divided by x squared plus 8x. All right, so let's suppose we had this one. Okay, so now what we have is two rational expressions with the same denominator. Okay, So at that point, just combine this into one rational expression. Since they have the same denominator, I can combine these two into one rational expression. Okay? Now the next step is to add the numerators. All right, so notice I have an x squared plus an x squared. So remember when adding polynomials, you're going to combine like terms. So x squared plus x squared is 2x squared. Okay? A negative 3x plus a positive 6x is a positive 3x, because a negative 3 and a positive 6 are positive 3. All right, so that's where I'm at. Now I've got to simplify this rational expression. So to simplify a rational expression, I'm going to factor. So if you look at the numerator, I can factor out an x. So I get x times 2x plus 3. In the denominator, I can factor out an x as well. So I get x times x plus 8. Okay? So once you get to that point, once you factor, okay, so remember the next step is to factor. Once you get to that point, then you reduce. You reduce your common factors, and I have some common factors I can reduce. It's only these factors of that. So those will divide out, and you're left with an answer of 2x plus 3, because 1 times 2x plus 3 is 2x plus 3, divided by 1 times x plus 8 is x plus 8. So leave your answer like that. There's your answer. Okay? You can't do anything else. All right, so that was number 8. Let's look at number 9. So in number 9, we have, let me make sure I'm going to get the right one. So number 9, we have this one, number 9. Let's go ahead and use this one. So this will be number 9. We have 4x squared All right, 4x squared plus 3x plus 5 divided by 6x squared minus 7x plus 1. And you're adding that to 5x squared minus 14x minus 3 divided by 6x squared minus 7x plus 1. All right, so we're going to add those two rational expressions. All right, so again, notice that those two rational expressions have the same denominator, so the next step is to write this as one rational expression with that denominator. So I'm going to get 6x squared minus 7x plus 1. And the next step is to add those two polynomials. So when I add those two polynomials, and let's put them in descending order, I have 4x squared plus 5x squared, so that's going to be 9x squared. I have a positive 3 and a negative 14x, a positive 3x and a negative 14x, which is a negative 11x. And then I have a positive 5 and a negative 3, which is a positive 2. Okay? All right, so once I combine these two rational expressions into one, remember the next step is to simplify this. Simplify these rational expressions. So remember, you can only reduce common factors. Notice that and some of you are going to mess up. You're going to say, well, I see some x squares. I'm going to divide those out. Those are not factors of the numerator. This is part of a term which is connected with all of these. All right, so you got to be careful. So you have to list this as a product of factors. So that's why we factor this trinomial. So when I factor this trinomial, let's see what we get. So hopefully I wrote this problem down correctly. So hopefully they'll both factor the way I wanted to factor. So for this one, let's go ahead and use 9x and x. I think that's the one that's going to work. And then let's put the 2 here, the 1 there. And then last sign's positive, so these signs in here are the same. So that's going to be both negative. And let's check. So 9x times x is 9x squared. A negative 2 times a negative 1 is a positive 2. 9x times a negative 1 is a negative 9x. And then the inner, that's a negative 2x, and I get negative 11x. Okay. The denominator, when I factor that, let's use 6x and x. And then the last sign is positive again, and so they have to both be 1s. And they're both negative symbols. And so therefore, let's check. So the outer is a negative 6x, the inner is a negative 1x, and when I add them up, I get negative 7x. All right, so I went from, so to simplify this rational expression, I factored. Now I see what their factors are. So their factors are 9x minus 2 and x minus 1 for the numerator. The denominator, the factors are 6x minus 1 and x minus 1. And notice I have some common factors in the numerator and the denominator that I can divide out. And remember that when you divide out, you get factors of 1. And so therefore the answer is 9x minus 2 divided by 6x minus 1. Okay? All right, so that's the answer there. Okay, number 10. So let's suppose in number 10, we have 6x plus 8 divided by 15 plus 4x minus 8 divided by 15. All right, so that's an easy one, right? So we're doing some little bit difficult ones. Now let's look at an easy one again. So the denominators, they're both alike. So I can combine this into one rational expression, and all I need to do is add their numerators together. So 6x plus 4x is 10x, and then 8 plus a negative 8 is 0. So I get 10x divided by 15. And so all I need to do, now remember, if you look at these are monomial factors, so you really, so to speak, can't factor in the normal sense that we would do. So we just reduce common factors. So notice that 10 and 15, the common factor they have, and the greatest one is what, 5? So 5, let me go ahead and rewrite this. So 5 goes into 15 3 times, and 5 goes into 10 2 times. And so I get 2x divided by 3. Okay? All right, number 11. Let's suppose number 11, we have 7x squared minus 6x divided by 3x squared minus 12x plus a negative 22x divided by 3x squared minus 12x. All right, so notice that the denominators are the same, so I'm going to write this as one rational expression. So 3x squared minus 12x is going to be that common denominator. And all I need to do now is just combine like terms in the numerators. So I have a 7x squared here, and I can't combine with anything else. But let's see, I have a negative 6x. I'm adding that to a negative 22x, so that gives me a negative 28x. Okay? All right, now the next step is to simplify this rational expression. Now, to simplify a rational expression, you've got to factor first. So if I look at the numerator, it looks like I can factor out a 7x, right? So I get 7x times, and then that's going to be x minus, what, 4? All right, in the denominator, it looks like I can factor out a 3x, so I get 3x times, and then 3x times x is 3x squared, minus, and then 3x times 4 is a negative 12x. And so now we reduce. Okay, so we're going to reduce this. So my first factor I see is a 7. I don't see a factor of a 7 in the denominator. Next factor is an x. I see a factor of x here, so those will divide out, right? The next factor I see is x minus 4. I see 1 here, so those will divide out. And so the answer is 7 times 1 times 1, which is 7. 3 times 1 times 1, which is 3. All right, let's look at number 12. Number 12, we have, so number 12, we have x squared plus x plus 5 divided by x squared minus x minus 6 plus 2x squared plus 4x minus 7 divided by x squared minus x minus 6. All right. Okay, so the next step is to add those two fractions into one since the denominators are the same. So in other words, I'm going to get these two fractions to one fraction with that same denominator, x squared minus x minus 6. All right, so in the numerators, let's combine like terms. X squared plus 2x squared is 3x squared. X plus 4x is 5x. And then 5 and a negative 7 is a negative 2. Okay, so I get that. All right, so now I need to simplify this rational expression. So to simplify this rational expression, I'm going to factor the numerator and the denominator. So in the numerator, the GCF is 1. So I'm going to go directly to the two binomials, and let's see what's going to work. So 3x and x. The last sign's negative, so these signs are going to be different. And I need a 5x as my middle term. So it looks like it's going to be this. Let me just double check. So we're going to make this positive, this negative. So let's check. 3x times x is 3x squared. A negative 1 times a positive 2 is a negative 2. The outer is a positive 6x. The inner is a negative 1x. And so I do get 5x when I add them up. In the denominator, let's see, x times x. The last sign is negative, so these signs are going to be different. And I need the product to be a negative 6 and the middle sign and the middle term to be a negative x. So it looks like what's going to work will be 3 and 2. And it looks like the 3 will be negative and the 2 will be positive. All right, and so now we reduce. So if you look at my factors, there are 2 factors in the numerator and then 2 factors in the denominator. My first factor in the numerator is a 3x minus 1. I don't see 1 down here. My next factor is an x plus 2. I see 1 down here, so that's going to divide out. And so therefore the answer is 3x minus 1 divided by x minus 3. Okay? All right, so I think we've done enough examples to get you through understanding the process that you're going to go through when adding rational expressions with the same denominator. In the next lesson, we're going to look at subtracting rational expressions with the same denominator. So instead of adding, you're going to see subtraction. All right, now with subtraction, it's one more little thing you got to be careful of, and that's when you're going to subtract this numerator. And so we'll talk about that in the next lesson. So that's going to be the end of this lesson.